Hi guys, welcome to lecture number 2 of our Delta PLC Programming mini course. If you've been following up until now, in the previous lecture we set up our Delta PLC Programming simulator so that we can test out our code and write some programs and actually simulate them on our PC as if it's a hardware PLC. So in this lecture we're just going to cover some of the basic fundamental programming functions to read inputs, energize outputs, set things so that they persist, and also do some resetting so that we can reset persisted outputs as well. So just to get started, open up ISPsoft, and the first thing we're going to do is we're just going to head over to this left bar here. I'm going to click on programs and we're going to right click and click on new. So what we're going to do is we're going to just do some ladder diagrams, and for those who don't know what ladder diagrams are, they basically got their name because they look like ladders. So when I click OK, you'll see that we've got this first network 1. This is also known as a rung. A rung is part of the actual ladder, and it's actually the steps of the ladder, and that's where ladder diagrams get their name from. Conventionally they were used because they were easier for the folks which do electrical work to understand, because they follow the same sort of logic as relays. So if you want to, like for example, add another rung in ISPsoft, you just click in this programming box and you can click on one of these arrows to either insert one before this rung or after this rung. So what we're going to do is just insert one after this rung. So we've got 2 rungs to play with, and let's just start with the very basic function. First one is we just click on the first rung, hit spacebar and type LDM0. So LD is just basically a function which allows us to get an input, and when it is turned on, it will allow the rest of the rung to execute. So for the conventional programmers, this is a lot like an if statement, and M0 is like a boolean, and for our electrical guys, this is like a switch where we push a button and it energizes and it allows current to flow. So once you've got your LDM0 in there, click OK, and you'll see that it creates a little box here on the left hand side. Usually on the left, the inputs will all sit on the left and our outputs will sit on the right. So while on this run, just click again and hit spacebar and type out M1. So just for this example, we're just going to delete this rung for now. We'll bring it back later. Now what we need to do is just go back to communication settings and make sure that we've got our simulator selected. Click on OK. And from here you can just click on online mode and also OK. So yes, we want to download, and OK. And OK, and then basically just need to make sure that this is in the running state. If it is not, then you'll just have to click on this button to run. And if you want to stop the simulation, just click on stop. So now we're in the run mode, and just to show you how this actually works, here we typed out M1, that means it is an output, and here we typed LDM0, which means it's an input. And what we can actually do while we're in online mode, you can click on this, right click, and we can say set on, and you'll see that this executes and then this executes and turns M1 on. So conventional programming, if M0 then M1. Ladder diagram programming, if this switch is on, current will flow, and this switch will, or this component will turn on, whatever that may be. Just to look at a couple of other functions, we're going to create another rung here. So click on this, click back on the second rung, type spacebar, LDI M2. So LDI is the inverse of LD, so when it is turned off, then this line will energize and run whatever function is on this side. So let's test that out. Add in and out M3, go back into online mode. And you'll see that M3 is turned on. So what we're going to do is just click on here and we're just going to set it to off. So you'll see when it's off, it's M3, it's on. When we set it to on, it will do the inverse and turn M3 off. So out is basically used for non-persistent bits. So basically if any of these values do not allow current through or allow this condition to become true, then these items will always be like turned off. So let's look at a case where we can make this bit persist. So let's just go out of online mode and create another rung again. So just for this example, we're going to use LDM4, and again this spacebar, I'm going to say set M5. So sets will basically persist M5 when M4 is turned on. So just to prove that concept, let's go back into online mode. So yes, okay. So turn M4 on and turn it off, and you'll see that M5 stays on. So in this case, if you wanted to turn an output on and keep it on for the program, sometimes we'd use this for like status changes within the program, just to have bits on which allow us to keep a state. But what if you had to wanted to de-energize M5 at some stage? What would you do? So let's again just go out of online mode and create another rung. So let's do LDM6. And we'll add RST as our function M5. So RST basically stands for reset, and I think it's quite obvious what this is going to do, but let's go into online mode and just demonstrate what it does. Great, so let's turn M4 on, so we'll see M5 is on, turn it off, and M5 remains on. Let's turn M6 on, and you'll see that it resets M5 back to its original state. So these are some of the really basic functions that you will probably use in your programming. So get to know them quite well. But while we're here, let's look at some other things you can do. For example, we could add in an additional condition here. So let's go out of online mode and let's click in there and we say and M7. So now basically M0 and M7 needs to be on for M1 to be on. So let's again go into online mode and test this. Right, set that on, so you'll see M1 is still not on until M7 is on, and then M1 will energize. If M0 is off, it will also not energize, so therefore these two need to be on. For your conventional programmers, what has happened here is we had LD M0 and M7, so that would have been your if condition for those two bits to be on or true, for M1 to be true. And for your electrical guys, once again, no current can flow because there is no current basically at this source, or if this one is off and M1 is on, current also can't flow through to M1. So some other things you can also do is you could do, for example, an OR M8, add that in, and put that into online mode just to show you what it does. So you'll see that M3 is now on, but let's turn this to on so that M3 is not energized, and M8 turn that on. So basically if M2 or M8's condition is met, M3 will turn on. So that is how you can chain different bits in a rung or use them in parallel and then do certain logic with it. And this makes it really useful because you can get specificity on all your functions and like your logic that you want to do. And guys, that's basically it for this video. I hope you've enjoyed it. If you want to see more of this mini course, subscribe to our channel, hit the notification bell so that you can be notified of any future videos. And if you would like to support us in any way, you can also book consulting times with us through our website if you need any automation help with any of your existing automation projects. And thanks guys, I'm glad you guys watched this, and I hope it was useful and entertaining. See you in the next one. Cheers.